Welcome to Nature's Guardians. I'm Micah Siegel. Each week, I talk with people working to save and help animals around the world. They are nature's guardians, and you can become one too. Today, I'm talking with Peter Ridd in Australia. Welcome to the show, Peter.
Thanks very much.
Great to have you. So, to start, tell me about your background and how you got where you are now.
Well, I live in North Australia, which is just opposite the Great Barrier Reef, and I actually trained as a physicist at university. But a job came up at the Australian Institute of Marine Science to work on the Great Barrier Reef, to look at the ocean, to look at the way the currents move around, the way the tide works, and all these sorts of stuff, which is actually physics. But essentially, it was really to look at the background environment of the Great Barrier Reef, because obviously the Great Barrier Reef is such an important thing, and the Australian government was spending a lot of money to make sure it was well preserved at that time. So that's about 35 or probably more than 35 years ago now.
Have you written papers and published about the Great Barrier Reef?
Oh yes, we've definitely. I've got written about 100 scientific papers, of which probably, I don't know, maybe 50 or so of those are about the Great Barrier Reef or about the associated ecosystems. So some of them are about, the physics, how sediment moves around corals. We did a lot of development of instrumentation to measure all sorts of aspects of the reef, but also more to do with the actual organisms such as sharks. They're really interesting because they actually use electric fields to find their prey. But mangrove swamps, mangrove crabs, and a whole lot of other creatures. But mostly it was on the physical side of how the water moves, how the sun goes into the ocean to heat it up, and those sorts of things.
We hear all kinds of things about the Great Barrier Reef. How is it doing right now?
Well, it's actually doing extremely well, which may be surprising because a lot of the news you see especially in the overseas newspapers, always says that it's dying from this, that, or the other. But actually, the statistics from the Australian Institute of Marine Science, which is the major reef study organisation, they've been surveying the Great Barrier Reef since 1985, and they measure how much coral is out there on it. And this year, we're at actually record high levels. We've never had more coral on the Great Barrier Reef since records begun, which is, absolutely fabulous news. But that news is being slightly distorted when it goes around the world.
Tell us about reefs all over the world.
Well, that's a slightly different story. Australia, our Great Barrier Reef is huge, right? It's 1,000 kilometers, it's 1,000 miles long. It's quite a long way from the shore. This coastline has got a very small population of, only about 1 million people along 1,000 miles. So there's almost nobody lives here. So the people pressure on the Great Barrier Reef is very small. But that's not true if you're, say, on some of the big islands on the Caribbean, where you could have, 50 or 100 million people who are in the Caribbean area, which is about the same size as the Great Barrier Reef, or some of the islands in the Indo-Pacific region, where you have a very large population living very close to the reefs. So they tend to be problems with overfishing, some pollution, and even just actual physical destruction of the corals by dredging. Say in the South China Sea, the Chinese government has literally built huge military bases on some coral reef islands. So although Australia's Great Barrier Reef is actually in, I would argue, extremely good condition, there's plenty of coral reefs around the world which have been pretty badly damaged over the last few decades.
What actually are corals and how did they evolve?
Well, corals are they're sort of animals that form. Well, I guess you've seen pictures of them. You have some that are big lump shapes. They can grow almost as big as a car or even bigger than a car. And others have these beautiful branching corals, or what we call plate corals. And they're made of a little animal called a polyp. And they grow a sort of a skeleton, which is like concrete. It's almost as hard as concrete. So that's the coral. That's an animal which has actually got a little plant growing inside it as well. But a coral reef is when, over thousands or millions of years, when those corals die, because they're basically made of a similar material as concrete. When they die on the seabed actually builds up. So our Great Barrier Reef is made up of 3,000 individual reefs. And each one of those reefs is maybe 1 or 2 miles long and about a mile across. And it's a pile of coral 50 to 100 meters, or maybe 150 to 300 feet high, that's built up over about 1 million years. And it's just made of dead coral and dead other organisms. So that's what a coral reef is. It's essentially a great big pile of dead coral.
What is coral bleaching?
Coral bleaching. Now, so coral bleaching is essentially when the coral goes white. So when you bleach something, it goes white. Why does it go white? Well, essentially, the coral, I mentioned before, the coral is a little animal with this calcium carbonate, or very hard, almost like concrete skeleton around it. But inside that little animal, and there's millions of those little animals to make up one coral block, inside that little animal, there's an algae called zooxanthellae, which actually lives inside the creature, which is a symbiotic relationship. And essentially that algae takes sunlight and produces food for both the algae and also the coral. So they live together. Now, it's not understood why, but for some reason, when the water gets very hot, or when it gets cold, actually, or where there's too much rain and the water gets fresh, or when the coral is just feeling really sick for some reason, the coral chucks out that algae. Now, because the algae has got a slightly browny, greeny color to it, when the coral chucks out that algae, it loses its color. And the natural color of just the coral itself without the algae is white. So the coral goes white, it bleaches. Now, the problem is that if it loses its algae, it loses one of its major food sources because it's getting energy from the sun. And it can now die if it doesn't take that algae back. So usually what happens when a coral bleaches, it survives, it doesn't die. So a lot of people equate coral bleaching with death. It doesn't usually die, but sometimes it certainly does. What will usually happen is that over the months after it's bleached, it takes back that algae, which is always floating around in the water, back inside. It may take a different species of that algae, which will make it less susceptible to bleaching in the future. And it is a bit shaken by the experience, but is quite fine.
So it sounds like corals are pretty resilient.
Actually, they are. And one of the interesting things about bleaching, which is often used as it's this some disaster, is actually part of their adaptive response mechanism. So if the water gets, so along our Great Barrier Reef, for instance, down towards the south, because we're in the southern hemisphere, the south, it's relatively cold. In the north, it's very hot. Now, when a coral spawns, it could drift to the south where it's cold, or it could drift to the north where it's hot. So it could be in cold water or hot water. And actually what the coral does is it chooses different species of this algae, depending on whether it's hot water or cold water, because that allows it to adapt to either hot water or cold water. It's actually a really cool mechanism that they have, whereas most other organisms, they have to go through many cycles of evolution and natural selection to change their genetic structure to be able to deal with hotter or colder water. What a coral can do is just bleach, chuck out that algae, get in a different type that's better for hotter water or better for colder water, and it's good to go, sort of thing. So very, very adaptive indeed.
Do corals have natural predators?
They most certainly do. Actually, there's the main predator is probably parrotfish that actually chew the coral. Now, I said it's really, really hard like concrete. So these parrotfish, which have got really, really hard jaws, and they chew it. And you can often see these marks on the coral where they've been chewing away with their jaws. I saw a calculation about how much coral parrotfish eat every year, and it's sort of like millions and millions of tons of coral is eaten every year by parrotfish just on our Great Barrier Reef. The other one is a very nasty looking starfish called a crown of thorns starfish. And they crawl over a lot of the plate coral and other types of coral. and basically dissolve it underneath. They sort of extrude their guts almost onto the coral and dissolve it and suck the nutrients out of the coral. And they're responsible for massive loss of coral. And in fact, that was the original. When I was your age, actually, we thought that we only just discovered how these crown of thorns starfish were chewing huge amounts of coral and destroying whole reefs. And in those days, in the early 1970s, they thought the whole Great Barrier Reef would be wiped out by 1980. It didn't happen, of course.
What are the main misconceptions about coral?
I think the main misconception about them is that they're extremely delicate as a general organism. Now, obviously, a little coral, you can damage a coral very easily just by standing on it. Right? You can damage it. But as an organism, as an ecosystem, they're actually relatively resilient. So, for example, I often say that if we have a horrible nuclear war and we just blow us up, all humans will be wiped out. There'll be some organisms which will survive, and corals is one of them because they've been through, millions of years of evolution. And when you see some of the terrible things that have been done to corals in some countries, once you remove that threat, once you stop the pollution, and once you stop that overfishing, they spring back remarkably well. So it's sort of like a good news, bad news stories. It's bad news that we've been doing this to some corals in some countries. But the good news is that if you just do the basics there and give them clean water and don't blow them up with dynamite to fish, they come back very, 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 very strongly. Well, an interesting thing about those parrotfish is that they actually make the sand on a coral island. So if you go to a coral atoll, and there's quite a few out here, lots in the Pacific Ocean and in the Caribbean, I dare say, a lot of that sand is actually caused by the parrotfish chewing the coral. They produce enormous amounts of it. Now, a lot of the other stuff is caused if a big hurricane goes through and smashes the coral. Eventually, it breaks down and forms sand. But yes, quite a lot is surprisingly caused by the parrotfish.
For the Great Barrier Reef ecosystem, what is your major concern?
Well, I'm not actually too concerned about the Great Barrier Reef because, as I say, it's very well protected. There's almost no fishing on it. It's a long way offshore, so it's not affected by the very small amount of pollution that does come off the land along this coast. I do worry about some of the world's ecosystems, but reef systems, but that's a separate thing. Now, along this coast, the farmers have been accused of their pollution damaging the reef. But actually, when you look at the measurements, and I worked on this for a very long time, so mud coming off the farms from soil erosion, is that killing the reef? We were able to demonstrate that no, it really doesn't get out to the Great Barrier Reef. When you look at pesticides, sort of like herbicides and those sorts of things that run off farms, they're in such small concentrations on the Great Barrier Reef that you can't even detect them, even with the most sensitive scientific equipment. So at least on this coast, the effect of farming is completely negligible. Now, that is not true in plenty of other parts around the world, but it definitely seems to be on the Great Barrier Reef. So summing up, I think that a lot of the stories about the Great Barrier Reef where you heard it's in terrible shape, it's just not true. And that actually it's one of the best preserved ecosystems on Earth. But that doesn't mean to say you want to be complacent about it. We mustn't be. And it also doesn't mean that there aren't serious problems on other reefs in other parts of the world.
Where do all the Australians get their shrimps?
Well, we call them prawns in Australia. But essentially, most of our shrimps actually come nowadays from Thailand. So we've actually clamped down on our shrimp fishing industry. We get a lot of shrimps from the Gulf of Carpentaria, which is a different, completely different environment. It's a bit like your Gulf of Mexico, except very shallow. So we get a lot from there. There is a small shrimp fishery along the Great Barrier Reef coast. But nowadays, Australia imports, despite Australia having, I think, either the biggest or the second biggest or the third biggest area of ocean in the world, just behind America, we are number 65 in terms of the amount of seafood we produce. And now we import about 70% of our seafood, mostly from Thailand. And by the way, that is a problem because I think that we are actually exporting our environmental footprint to another country. So they are then probably overfishing and we are probably underfishing, if you know what I mean. So we could take more fish than we do. We've elected not to, but what that then means is that the Thailand people might be overfishing their waters. I suspect they are.
What are your main concerns about science in general?
Well, firstly, science is obviously wonderful, and science has pulled us out of the dark ages and giving us everything that we have around us. But I do have concerns that some of the science that's coming out in the last couple of decades is relatively unreliable. Now, it's not just me saying this, that studies have shown that when you check scientific papers, so the type of stuff you might see on your news feed, it turns out that roughly 50% of that, the scientific papers that are coming out in the last couple of decades, have serious problems with them. Now, this is not just me saying this. The big institutions, the Australian Academy of Sciences, the American academies, the British academies are all saying that a lot of the stuff is not as well checked as it should be. Now, the stuff that we're using for most everyday stuff, like for computers, for aeroplanes, for engineering, that has been really, really well tested. But in fact, most of the science you hear on the news feed actually hasn't been very well tested. And a lot of that has turned out to be wrong. And that's actually damaging the reputation of science. So there's a lot of people who are now not believing the science on a range of things. We can go into those if you like. And that's bad because we've got to be able to have science that we can trust. And then if we can trust it, it's important that people do. But we've got ourselves into a situation where a significant amount of the science that's coming out is wrong. And then that discredits science. And then people don't believe science that actually is correct. So that's my main worry.
Why do you think we hear so many false statements about science in the news?
So one of the reasons we get false news is because the actual science is false in the first place. Now, the other reason we get some false news about science is because the media tends to, always want a doom story and they blow things up and they twist the story.
If kids really want to learn real science, what should they do?
Well, you've obviously got to be good at science at school. You've got to study. Don't shy away from the difficult sciences, all right? Physics and chemistry. They are behind everything. And one of the problems is that people tend to do the easier sciences, the biology and the environmental sciences. And in the end, they're nowhere near as useful as a scientist, or they're likely to be nowhere near as useful as if they've done a little bit, not a huge amount necessarily, but a little bit of the basics of chemistry and physics. So don't miss the basics, chemistry, physics, and the mathematics, because mathematics is often behind a whole lot of this stuff.
I was hoping you wouldn't say that.
Yeah, well, maths, it can be hard, but as I say, it's really behind everything. So you just got to suck it up and get reasonable at it.
For the next 30 years, what do you think is coming for the Great Barrier Reef and reefs in general?
Well, we're going to see the Great Barrier Reef go through these big swings. So, I said we're at record high coral this year. If you go back to 2012, we had less than half as much coral on the reef then that we do now, because we'd had these huge cyclones, we call them cyclones, you call them hurricanes, came through and smashed a huge amount of coral. The starfish were in plague proportions and everything was looking terrible. And now it's looking really good. Well, I can guarantee you that sometime in the next decade, it's going to not look so good. That the reef goes through these big swings and changes, and that's going to happen on the Great Barrier Reef. It's always happened. You remember that I said that reefs are made of a pile of dead coral. Well, the coral's got to be killed somehow to build up these reefs. Now, for the reefs overseas, I think what we are going to see is more and more conservation efforts to protect the reefs. If you actually look at the statistics of the world reefs, they have not declined in the amount of coral. in the last 20 years, which is a good sign because it means that we're not getting any worse at the moment. And I think that as countries become wealthier in the Southeast Asian region, and they can actually spend more money on preservation, I think that we will see the general improvements in the coral reef situation, provided those countries actually go about that. So I think the actual outlook of corals is not that pessimistic, provided we do the right things, which you're nowadays seeing that happen.
How can kids like me help fix science?
I think you just got to keep asking for quality assurance, checking of the science, to always be skeptical of everything. It's really important you're always skeptical of absolutely everything all the time, and never accept when people say things like the science is settled, right? Because you never know when there's going to be a breakthrough or some new piece of information will come along which will change your mind. So keep an open mind on science all the time. You can't go too far wrong.
Thank you, Peter.
Well, thanks for asking me to talk about the Great Barrier Reef and corals. It's been great.
And thank you for watching. You can help animals by hitting a like button and subscribing to this channel. I'll see you next time on Nature's Guardians.